Now we have to find out the moment of inertia of this given surface. Now this surface is not having any standard shape. We cannot find out the moment of inertia of this surface about this axis. This is x-axis. About this axis we have to find out. Now this surface we cannot find out directly. What we do to solve this, if I say we have taken a triangle here, means if I drop a perpendicular I am getting this triangle, and if I drop a perpendicular I am getting this triangle. So I can say what is there. First surface is a triangle, this one. Second surface is a rectangle or square, whatever, the middle one. And then the third surface is again a triangle, this one. But after that there is no surface here, but in these if I join them, there is the surface in between these. So there is the another surface, I can say the semicircle, which we have to subtract from these three. Means how we solve the moment of inertia of these three surfaces, then we will subtract it from the moment of inertia of this semicircle, then we will get the moment of inertia of the given object. So in this way we can break the surfaces. So let's see. First, if I give the name, it will be easy to understand. If I give the name, let's say this is A B C triangle. Okay, and listen the dimensions. It is 3 centimeter, 6 centimeter, 3 centimeter. Don't get confused. It is 3 centimeter here, 4 centimeter and 6 centimeter, right? Now first is a triangle, that is ABC. So we will solve like for triangle one by one. I will give the name and then I will solve. So in triangle ABC we will calculate all the values to find out the moment of inertia. Now first in the triangle, what is the area? Let's say this is area A1. Now that is the area of a triangle, that is half into base into height. Now what is that? Half into 3 into 6. 3 base, 6 height. So that is coming equals to 9 centimeter square. Now for the triangle we know that where the centroid will be. Centroid y1, we can say centroid y1 means here will be the centroid. We know that this one, and we know that that is how much, h by 3. So h by 3, we have solved a number of numericals on the same. Directly I am putting the values. So this is 6 by 3 and we are getting 2 centimeter for triangle. Now this is the centroid. So if we know the formula of a triangle for centroid, it means it is about this axis, right? I'm again telling you, this is the triangle only. What we did in that, this is A B C. We have calculated the area. Then we know that for this, the centroid, this is the centroid, from where it will pass, h by 3. So this is h given and we get the h by 3. So this is the centroid or the center of gravity. So the standard formula will give me the value about this axis. Then I will shift it about this axis using parallel axis theorem. So we know the standard formula for this. If I say Ix1, if this is the calculation of first surface, so the moment of inertia about x1, that is equal to bh cube by 36. This is the direct formula to find out the value of triangle about this axis for moment of inertia. So we have b. Now what is the b here? That is this one, 3 into h. We have the value of h, that is 6 bh cube by 36. So if I find out, it will be 6 only. So that is 18 centimeter power 4. Now this is the moment of inertia about the centroid axis, but I have to shift it here. So what we do, we can say about now x axis, not about x dash axis. That is what we know, bh cube by 36. The same formula we have calculated, plus a into h square. So this value we are having directly this, plus now what is the area of this? What is that? We have calculated 9 into h square, the gap between these axes, that is again h by 3. H by 3 we have calculated 2, so that is 2. Now this is what, 18 plus 18, that is 36 centimeter power 4. Now this question can come in the two ways. I have given you the question when we have to find out the moment of inertia about this axis. So for all the 3-4 figures, we will find out a moment of inertia about its own centroid, its own center of gravity. Then we will shift using parallel axis theorem about this axis. The second way how they can ask you the question, they can say the same object but find the moment of inertia of this object about the centroid of complete object. Means we have the 4 surfaces, we have to find out the center of gravity of this surface, then about that axis we have to find out the moment of inertia. So in that case we will not apply the parallel axis theorem here, we will only find out this moment of inertia of first objects in second, then third and fourth. Then we will find out the centroid, center of gravity of this structure. We have the formula a1x1 plus a2x2 plus a3x3 and minus a4x4. Similarly for y bar, a1y1 plus a2y2 plus a3y3 minus a4y4 divided by a1 plus a2. So the same formula we will use and find out the centroid or center of gravity of this structure. Then we will draw the axis over there and we will shift the moment of inertia from this centroid axis to the centroid axis of the complete object. So that will be also an interesting question. If you want to do the practice, you can solve the same question. Find the moment of inertia of the same object about the axis passing from the center of gravity of the same object. That will be more interesting. Now let's see, we will complete the same question for second object. Now that is what, for a rectangle. So now we will give the name. The rectangle is, let's say we have given up to C, so we can say CD. So let's say E and B. So the rectangle is CD, E and B. In this rectangle, now what is the area? I can say area A2 for rectangle, that is equal to directly P square, because it is having direct 6 and 6. So this is a square, or we can say square or rectangle, that is 6 square means we can say the B square, that is 36 centimeters square. Now we will find out the centroid. Again we need y2 because we have to find out the moment of inertia about this axis only, that is why we are calculating y only. So what will be that? Again half of the height, so that will be y2, that is directly we know the formula b by 2, that is equal to 6 by 2, that is 3 centimeter. All these things I have covered in the previous video. If you have any doubt regarding this, do watch the previous video, then it will be more clear. Now we will see the moment of inertia for this object about the same, about the axis. Now I make the diagram for this. This is the centroid, but we want to find out the moment of inertia about this axis. Means it is, we have the formula directly from x dash axis, but we want to find out this, so we use the parallel axis theorem. But about this centroid axis, what is the moment of inertia formula? That is bd cube by 12. Direct formula is there. So what is that? B parallel to that d, that is 6 into d cube, that is again 6 cube divided by 12. So this is 108 centimeter power 4, that is about axis passing from center of gravity. Now we have to shift about x-axis, so I will say 2. About x-axis, that will be pd cube by 12 plus a into h square. So h is the distance between these two axes, so we have the value of bd cube by 12 we have calculated, plus a, area of this, that is 6 into 6 into h square. H is the distance, means that is again half of that, so it is 6, so this will be 3 into 3 square. After calculation we are getting the value, that is equal to 432 centimeter power 4. Now third is again a triangle, this one. Let's see, we give the name to this triangle. Now this is DE, let's say this is F. So for triangle DEF we do the same area. So what is the area? Means we can say A3, area A3, that is the triangle, area of triangle, that is half B into H. So we have the value of B base that is 3 and height that is h 6, that is equal to 9 centimeter square. Now what will be the centroid? Centroid means we can say y3. I need the values of y only because axis is along the x-axis, so that is why we are calculating only y. So we want to find out this value. This is h by 3, we know that directly, so we can apply, that is h by 3. H, we have the value 6, so that is 6 by 3, that is directly we are getting 2 centimeter centroid. Moment of inertia about the center of gravity axis, then we will shift on the x-axis. So same what we have done in first case. So about this x dash, we have the direct formula, that is what, bh cube by 36, that is equal to b base, that is 3, h cube 6 cube divided by 36, so we will get 18 centimeter power 4. This is the value of some moment of inertia about x-axis passing from the centroid. Now we will find out the moment of inertia about this axis. By parallel axis theorem we can shift it here. This is about now x-axis only, that is bh cube by 36, means from this center of gravity axis plus a into h square. So we have the direct value for that, plus a, area of that, that is we have calculated 9 into h square. H is the distance here, and that is again same, h by 3, so this is 2 square. So after that we are getting 54 centimeter 4. Same in this part, it should be 2 power 4 a h square na? So I forget to mark h square, so this is 9 into 2 square, so that should be again, this is the calculated wrong value, so this is 54, something like this. So these are the three surfaces. Now we will see the fourth one. What is that? We have to subtract this, so let's go for the fourth surface. Now what is that? That is the semicircle, and we can say the semicircle, we have the value for semicircle. Now area for the semicircle, we have pi r square. For the complete circle, half of circle, that is divided by 2, so this is 3.14 into r, that is 4 square. Radius is given 4, so 4 square divided by 2, so that is what, 25.12 centimeter power 4. Same we can find out the centroid for semicircle. Now we are doing this thing, we know that, so this value, we know the formula, that is what, 4r by 3 pi. We are going to use the same, so centroid will be 4r by 3 pi. Please, I'm telling, if you are having confusion in all these, just do watch the previous videos where I have calculated all these things separately, so you can go through from all those numericals. So this is 4 into radius 4 divided by 3 into 3.14. Now I'm getting the value, that is 1.698 centimeter. Now we will find out the moment of inertia about this centroid axis. What is that? X dash. Now we have the direct formula, that is 0.11 r power 4 for the semicircle. I have covered all these things in the previous topics. So the power 4, that is equal to, we are getting 28.16 centimeter power 4. Now we will shift the moment of inertia about this axis passing from the center of gravity to the given axis x, and we need this h distance. So we know that is what, x4, that is equal to 0.1 r4. This is the value of moment of inertia about centroid plus a h square, and that is what, we have this value 28.16 plus area of this, we have calculated area, that is 25.12 area into h square. Now what is the distance? H is again what, 4r by 3 pi, so this is 1.698 square. So after calculation we are getting the value of this 100.586 centimeter power 4. So this is the fourth surface, we are getting moment of inertia about this. This is the third, this is the second, and this is the first. So we know that moment of inertia about this axis, that is equal to moment of inertia of 1 plus moment of inertia of 2 plus moment of inertia of 3 minus moment of inertia of 4. So we have the value moment of inertia of first, that is 54, plus second, that is 432, plus third, that is 54 again, minus 100.586. After calculation we are getting the moment of inertia of the given object, that is 439.41 centimeter per 4. So this is the final answer. I have find out the moment of inertia about this axis, x-axis. Just try to find out the moment of inertia about the centroid of this object. Now for that purpose, what to do? Do not make this calculation first. Find out the centroid of the complete object, then shift the moment of inertia from these center of gravity point to the given axis. Find out that distance and then it will be in the same way you can solve it.